Each week, a group of mathematicians and educators get together to discuss a beautiful problem or puzzle that might be good for the classroom. This week, Asmita presented pentomino Sudokus. So let's just look at, you can imagine what that might look like. It might look like something like this. And this is an example of a total failure because you know the rules. You can't have a shape like this that has two threes in it. All of the numbers in each of these pentominoes must be different. It also fails because each row and each column has to have all of the numbers and not duplicates. So here we fail also because this column has got two twos in it. But I thought, after leaving that, I wonder, can we generalize this puzzle? Can we find a more general template? And so this could be a typical puzzle that you might find. I don't know if this has a solution or not, but this here, you have these 5 numbers that are hints, and then you try to fill out the rest of the canvas. But a more general puzzle is to say, okay, I'm going to give you a bunch of number hints, and I'm going to give you a bunch of pentominoes, but not all the pentominoes. And you have to both tile the rest of this canvas, and you have to fill it in with numbers. So how might we solve this puzzle? So take a moment and try to solve it yourselves. You cannot have any duplicates of the pentomino shapes, so that's an additional constraint with this puzzle. Okay, so the first thing you might guess is this here. Well, there can be no ones in the bottom of this red shape, so in order for this red shape to have a 1, it has to appear there. So we know that that's a 1. And now we can complete that row. That row's obviously completed with a 5. What else can we do? Well, we can look at this column. What I guess in that column, we're missing a 1 and a 2. But in the row that contains that question mark, we already have a 1. That means that that must be a 2. And we can complete that. Now the 5s can either go there or there. And right now we don't know which. So let's assume that the 5s go there. Then tell me about the shape that contains this 5. Well, we have to be careful. We can't use this shape because the red shape already has that. So it can't be that shape. What other shape could we use? Well, there is only one shape that doesn't contain 2 5s, and that is this shape. So we know that that's going to be the shape moving forward if we have this 5 configuration. Okay, so this is all under the assumption that we've got those 5s in that position rather than the other one. Okay, so let's keep on going. What is that? So it is either a 3 or a 4 based on the bottom row. But look at this. Both of those have to have the same number. Convince yourself that that's true. Okay, well, it's obviously can't be a 3 because it's sitting in the same row as a 3 on the top. So actually both of those are 4s. And that means that at the bottom, we can complete that with a 3. And that's a 4 there. Because that's the last 4. There's only one other place for that last 4 to go. We obviously need 5 4s because we're going to have 5 pentominoes. So we obviously need 1 4 in each pentomino. So we know that that has to be a 4 there. Okay, let's now look at this green shape that starts there. Well, all the 3s that green shape can reach are already out on the board. And all the 4s that green shape can reach are already out on the board. And unfortunately, we can't reach both a 3 and a 4, right? So that means that we've got a problem. That means that this arrangement of 5s in this direction, that's not going to work. We have to choose the other direction of 5s. Okay, let's keep going. Okay, what do we do now? We can again question this. And that is going to be a 4. It's the only number that works with the column and the row. And that makes that a 3. Now, take a second, figure out what that is. Well, it's either going to be a 2 or a 3 based on the row, but we know that the one next to it has to be also a 2 or a 3, and because there's a 3 in that column, we know that it has to be a 2. Okay, done. Now this shape here, this blue shape, it has to contain one of those 3's. We've got 3 3's that are not connected to a shape right now. There's only one of those 3's that can be part of this blue shape. The others are too far away. So we know that this is also blue. Now, how do we link those two? Can we go like this? Well, we might go like that, but that means that we can't leave this space surrounded. So the important one is we have to include that as blue. So now we don't know. Is it going to be to the left or to the right? Are we going to go and include this one, or are we going to go and include that one? So we don't know which one of those it is. But if we included that one, then what's true? Well, let's not make that decision yet. Let's instead go back and look at this green shape. So we don't know if the 1 or 2 is going to be blue, but we do know this green has to be connected to a 5. Okay, so it's either this 5 or it's this 5. But of course, this won't work because you've sectioned off just four squares on the right. So if we're choosing that 5, we have to do this. So which of these is it? Is it the green across the top, or is it this green? Well, in either case, we know that that 2 belongs to the blue in both of those cases. So we've got that blue shape for sure now. Now we just have to figure out the green shape. Which of those 2 is correct? So if that was true, then you can see that the gray is the same as the blue, right? So we know that the 2 shapes can't be the same, and the gray and the blue are the same here, so that doesn't work. Okay, so we know that this has to be the green shape, and then that has to be the shape left over, and now we've got all of our pentominoes. Now it's we only need to solve for the numbers now. How do we do that? Okay, well, let's do this. What's that? That has to be, it can't be a 2, so it has to be a 4. Okay, there we go. That has to be, oh, and now it's just easy. And we've finished. Now, this was the initial puzzle, and you can imagine these puzzles are fun to make. For example, here are 3 of them, where I'm only changing one number at the top, and they all have a unique solution. We find the solution only for the one on the right. So go ahead and enjoy solving those other ones, and tell me what you think of this puzzle in the chat below. Take care.